So last time, we talked about the quadratic formula as this Swiss Army knife formula. It's a formula that works to solve any quadratic equation as long as the quadratic equation that it's solving has the form where one side of the equation is equal to 0 and the other side of the equation has its terms listed separately. So I've got an x squared term, I've got an x term, I've got a constant term, and then I have these coefficients. The coefficient of x squared, call it a. The coefficient of x, we'll call it b. And the constant term, we'll call it c. And so if I'm solving the equation ax squared plus bx plus c equals 0, and if I don't want to use factoring, or if I've tried factoring and factoring didn't work, then we can use the quadratic formula to spit out the solutions. How many solutions can a quadratic equation have? Two. It could have two solutions. Is that always going to happen? No. What are the other possibilities? It could have one solution. It could also have none, right? According to the fundamental theorem of algebra, 2, because 2 is the degree of this equation, right, is the maximum number of solutions that this equation could have, but it could have fewer, depending on what happens. So I asked you on your quiz a minute ago to write the quadratic formula. And what I've shown up here are 9 different responses that you wrote down. One of these 9 is the quadratic formula. The other 8 of these 9 are not quite the quadratic formula. So one of the things that I hope this course will help you learn how to do is how to read an algebraic expression critically, right? To understand what are the pieces that make up that expression, how the symbols that you use are conveying certain kinds of meaning. And for the quadratic formula in particular, there's a lot to remember. There's a lot of different operations going into this formula happening in a particular order, arranged in a particular way. And if you remember even one of them out of place, the quadratic formula is useless to you. So if you're going to take anything out of the discussion we've had in these 2 classes, if you're going to memorize anything at all in this course, this formula is a pretty good one to have in your memory banks because of its versatility, its ability to solve any quadratic equation whatsoever. So I want to take a look at these 9 and get your votes. So these are 9 that you just created. I'm going to number them here. 1, here's number 2, here's number 3, 4, 5, 6, 7, 8, and 9. And I want to quickly just take a vote. So take a quick look over all 9 of these, and I'm going to ask you to vote on which one do you think is the accurate quadratic formula. So which one of these do you think is the quadratic formula? It's number 8. So as a collective, you've identified the right one. So I want to look at some of these others that you didn't choose and point out some of the more common memory errors that happen when people try to drag the quadratic formula out of their memory banks and they mess something up. So first of all, looking at number 4, what's wrong with this one? What's this one missing, or what's this one doing incorrectly, Laura?
It doesn't have the negative b.
All right, so the first thing it's missing is the minus sign in front of the b. So that's missing. Is there anything else that number 4 needs? I claim there's one other really important thing that 4 is not doing correctly. So comparing 4 to the winner, what's the difference? Now that we've added the minus in front of the b, what else? Yeah, plus and minus is there in both. 4 uses parentheses to indicate its multiplication, which 8 doesn't, but I'm okay with that. There's one other crucial difference between 4 and 8. Yeah, that's the big problem with number 4. Look at where the fraction bar is in number 4. Right? In number 4's expression, what is being divided by 2a? Everything inside the radical, but what's not being divided by 2a is the minus b that's out in front. So that's the big thing that also, when people misremember the quadratic formula, this happens a lot, by the way. So if you wrote this one, you're in very good company, not just in this room, but in general. We really do need that fraction bar to go all the way across, because it's not just the radical that gets divided by 2a, it's minus b plus or minus the radical, all of which gets divided by 2a. So that's a really fundamental, it's an important difference. Let's look at a couple of these other examples and see what else is going awry. So how about number 2 up here? What is number 2 doing or not doing that separates it from the quadratic formula? Why is it incorrect? So number 2 isn't working for us because underneath the radical is written a plus sign, b squared plus 4ac, when what we want underneath the radical is b squared minus 4ac. It also has that fraction bar issue that number 4 had, so let's add that in here as well. Extend that fraction bar all the way across so that the minus b is also part of the numerator. Let's see. Number 9. What's wrong with number 9? The same thing about the fraction bar, for sure, right? This fraction bar needs to go all the way across. And it's missing the negative sign in front of the b. So just kind of taking an informal survey of the things that people misremember about the quadratic formula, what are some of the themes that you see showing up here? What are some of the common errors? Yeah, the first thing is the fraction bar. The fraction bar, the signs. And the signs happen in 2 places, right? The minus b in the front. Don't lose that minus sign. But then also, underneath the radical, b squared minus 4ac, as opposed to b squared plus 4ac. Right? Excuse me. Are there any other common threads here that are tying some of these together? What's number 7 missing? Yeah, it's missing the operator in between the minus b and the square root of b squared minus 4ac. So this person got it almost exactly right, but in between the minus b and the radical, we need that plus or minus sign. So if this person were to try applying this formula to solve a quadratic equation, this person would only ever get one answer out of it. Right? That plus or minus, I mean, the biggest thing that it does is it allows for there to be 2 different solutions. Once we've evaluated it once using the plus and then again using the minus. So the point of this whole exercise is kind of twofold. First of all, to point out that you probably don't remember the quadratic formula as well as you think you do. And the second point is there are a few sort of common things that people misremember about it, that if you can just spend some time staring at them and better understanding how the pieces in this formula stick together, you'll have a lot better shot at pulling this out of your memory banks when it counts on the exam.